Hello, everyone. Welcome back. So today, I want to talk about the logarithmic change of base formula. So how we can go from one base to another. So our goal is then to be able to understand how to use it, how to convert from one logarithmic expression to one base to another, and also be able to use that then to actually approximate a valuable logarithmic expression that's in kind of an inconvenient base. So the formula looks like this, as it says. So to change from some base A to base B, so they're both valid bases. So if you have log base A of some number C, then basically it changes to a fraction. So it's our new log base B, in both cases, log base B of C divided by log base B of A. Okay. Now, maybe probably easier to remember it this way. So this is below, where it says basically you're changing from a log of the old base of some value. What we do then is we change that to basically in both cases the log of the new base, the log of the new base of the value, and then the log of the new base of the old base. Okay. And once again, it says you can use this formula and change from one base to any other base as long as both bases are valid, as long as the bases you can use. This is also why a lot of older scientific and graphing calculators only had base 10 and base E, because they didn't need any other base. Now, a lot of the modern ones, can also Desmos, websites like that, you can use kind of convert any base, calculate any base, but that's why a lot of the early ones didn't, because you didn't really need it. You can use this change of base formula. So let's take a look at some examples over here on the right using this. Okay, number one. Let's say we have this. So let's say we have log base 2 of 7. Okay, so log base 2 of 7. Now, once again, there are many opportunities, many ways, especially on the web, to answer this right now. But early days, if you had a log base 2, that would have been harder to do. So what you want to do then is let's do a change of base. And let's also change that. Let's change to log, so log or just log base 10. Okay, and so using our formula, so let's just kind of rewrite our original expression, log base 2 of 7. And here's a way to think about it. So we're changing this to log, So log, okay, so we have log base 10 in both places. And essentially what we do then, think of it, is basically it's the log of the new base of the new value, which is 7. And then we put the value up here on top, and then the log of the base down here. Okay, so log base 2 of 7 is, once again, this is, remember, log is log base 10. This is now log base 10 of 7 divided by log base 10 of 2. Now, you can also change any other log as well, okay? So we can also do this. Let's say we want to change to natural log, okay? We can do that as well. So that's going to be log base 2 of 7 is equal to, so we put natural log in both places, up top and below. So we have a fraction. Oops, wrong pin. So with natural log here, and once again, what goes on top is my value, 7. What goes down the bottom is my old base, 2. Okay, now these two values are equivalent. Let's see that. Okay, so let's go to Desmos. We can actually do this. So go to Desmos, desmos.com, at the graphing calculator. Of course, we can graph with Desmos. We can also just do basic calculations. It's also a good way to show this. All right, so first off, let's show you you can use Desmos to actually just do any log base you want. So click on the keypad, go to functions. And now this is actually listed in the calculus functions. You have to scroll through several of these. Calculus are right here, okay? It said log base 2, then go the arrow, then 7. Close your parentheses, okay? That's what the value is, approximately 2.81 if we use two places. Now, let's do what we just said. So let's also do, now here I can just do log of 7, and then divided by log of 2. Notice that's exactly the same. Or if I do natural log, I can do ln of 7 divided by, sorry, wrong button, divided by, there we go, ln of 2. You see, that's also exactly the same thing. Now, to be clear, let's make one point. This does not mean that log base 10 of 7 and log base natural log of 7 are the same. They're not. But these fractions are equivalent. Okay. So these things are all the same. So actually, I can do any other log I want. If I want to do, log base 3, I could do it the same way, use the same change of base formula, I get the same result. Okay, so let's go back to our, so this is approximately about 2.81. So both these are approximately 2.81. Okay. All right, let's get another example. Number 2. You can do something kind of unusual like log base 1/3 of 8. Okay. Now, this one, let's change to how about log base? Let's just change the log base 2. Or no, let's do something different. Let's change the log base 5. Okay. So if I do that, then, and once again, of course, I can still use log base 10 or natural log. Let's just do a different log. Okay. So log base 1/3 of 8. Okay. Once again, we have a fraction. We have our log base, our new log base here and here. And using this idea, so it's the log of the new base on top and bottom. Then the value we're trying to find goes right here, 8. And then the old base goes right here, so log base 5 of 1/3. Okay. So let's go back to Desmos and let's try that. Now here, I have to go back to the calculus functions again. Okay. So log base, the log base 5 of 8, then divided by, oops, I did that again. So let's go back, divided by, hit enter by accident. Now, I can also go back to functions, but also I can just copy this expression. This is a little bit quicker at this point. Go below, and then I'll just change this to log base, and then just do 1 divided by 3. And, oops, actually that didn't work. Hang on. I accidentally copied the whole thing, so maybe I'm wrong. Maybe this won't work the way I want it to. There we go. Okay. Then make sure you correct it. So 1/3. Right. That's about negative 1.892. Okay. And we can also check to make sure that's correct. Let's actually, I should have done the original to begin with, but that's okay. Let's go back here. Once again, to these same calculus functions. So log base 1/3 of 8. Yeah, exactly the same thing. That's about approximately negative 1.89. Once again, use whichever log I want. This is approximately negative 1.89. Okay, so that's how the change of base formula works. Just remember this. So changing the log of your old base of some value. So it's the log of the new base in both places. Then the value goes on top. The old base goes to the bottom. And so we get that. Now let's do one quickly. Let's do one equation. Let's solve an equation and show how we can use the change of base formula to help us out. So let's say we have this. So we have 2 to the x plus 1 is equal to 5. Now, you might have seen a previous video of mine about solving exponential equations, where I would say generally you take the log, any log of both sides, and typically also you want to do log base 10 or log base or natural log, because those are the ones you have in your calculator. But in this case, we can actually just, you're probably thinking, why don't we just simply use log base 2? And we actually do that, and we can actually use the change of base formula to help us out with that. Okay, so this case, let's take log base 2 of both sides. This will get rid of the exponential. So log base 2 of 2 to the x plus 1 is equal to log base 2 of 5. Okay. Now, hope you remember that log base 2 and base 2 essentially cancel each other out. They're inverses. And so this becomes x plus 1 is equal to log base 2 of 5. Remember, log base 2 of 5 is just a constant, just a number. So finally, just subtract that. And so we're going to have, subtract 1 from both sides, x is equal to log base 2 of 5 minus 1. Now, once again, we can, of course, use a program like Desmos or modern calculator to calculate this, but let's change the base. And I'll just pick natural log Of course, you can use any log you want. Let's use something that's best to use. Okay. So once again, let's use this. So we're going to make a fraction. We have natural log on top and on the bottom, log base e. And the top goes the value, natural log of the value over natural log of the base minus 1. Okay, and then that's our answer. Then we can approximate that. Let's go back and take a quick look on Desmos. So let's go down here and do another calculation. So first off, let's do the value as it's listed, as originally shown. Where there's, I went too far. There it is. So log base 2 of 5, and remember it's also 5, then minus 1. Okay, that's about 1.32 to do places. Now, let's show this is equivalent to what we just said. So let's do natural log of 5 divided by natural log of 2 minus 1, exactly the same thing, about approximately 1.32. So that's how we can use also the change of base formula then to help us solve equations. So this is approximately about 1.32. Okay, so what we've seen then is how we can use the change of base formula to change from one base to another. And this is especially really important for more modern calculators because this is the most common calculate are the most common bases you'll see, log bases you use on regular calculators, are log base 10 and the natural log base e. And that's the reason they didn't really need anything else, as I said, because they had this change of base formula. Now, modern programs like websites like Desmos, modern calculators can do any log base, but this is still a very useful thing to have. Okay. All right. So that's how you use the change of base formula to go from one base to another and approximate any log you need to. Thank you. Have a good day.